Hey there, welcome back to Let's Make a Game. I'm Chili, and today we are going to be making a screen system for our game, among other things, but we'll get into that when it happens. First of all, I need to make an announcement. I have a problem. I am addicted to playing Magic the Gathering right now, and I need you guys to enable my problem. Anyone who's interested in flopping down some cards, come down to the forums here and make yourselves known, and we'll get a little magic group going. But yeah, enough about my personal problems. Let's get on with the system. So yeah, whatever. What shall we do first? It's been a while. We'll have to open up our project. And we will go to, where is it? We're going to go to unsynced commits. You're going to synchronize. And that should pull all of the new stuff off the server on GitHub. Then you go to branches, you go new branch, and you're going to pick the next thing, which is going to be, where is it? Lap timer. And create branch. And here's our lap timer branch. So what happened? Well, the easiest way to figure that out is just to build it. So let's start without debugging and see what we did. So as you can see, I've added a little display. Whoa, shit, fuck you. No, god damn it. Okay, this is gonna be hard. Oh yeah, right, I can't, it just stops. I'm used to a version that I've been working with that it's a little easier to work with. Let's just say that. All right, so this thing counts your laps and gives you the times for each lap. Displays that on in the top right-hand corner. Now, in order to demonstrate that, I have to actually make a freaking lap, and that might not be possible. Oh, geez. Oh, fuck. Okay. All right. Okay, I know how to fix this problem. We're getting off to a real great start here. Yeah, we're gonna definitely tweak the controls and everything later on. Don't worry about that. This is not indicative of the final product as I have imagined it. Not that I have a real perfect idea of where we're going. I just it's not going where we are right now. That's for sure. Okay, what we want to do is we want to take the damage and we want to bring it down by a factor of 10. And now I should be able to make it around this track without blowing myself up. Let's see here. Yeah, I've been quite busy lately. I'm pretty far ahead on where the code is, and I've added a nice sound effect system. It sounds really sweet. It's I don't know. It's funny how much just adding sound effects can change the feel of a game, the game feel. Okay, you can see now that I've got, oh fuck, okay, that I've got lap 1 is already been completed. Now I'm on lap 2. And there we go, we got lap 3. So you get the idea of how that works. No problem. Now the question is, how did I implement it? I'm not going to spend too much time on this because it's pretty simple. But just to go over, I'm going to undo this so I can change branches later. What do I want? I want to go to changes. Changes. Let's go view history. And we can see I made 3 commits in this branch here. Add lap timer, add lap display, and fix something. So let's go here first. So to the ship, I added a new class called the lap timer. And all this thing does, as you can imagine, is it keeps track of the times of every lap. So it is an observer. And it observes what? I think it's hooked up to the, what do you call it? What the fuck did I call that thing? Track sequencer, maybe? I think it's hooked up to the track sequencer. Let's see. Yeah. So here we've got the timer, which is our lap timer, and its constructor takes a sequencer. And it adds itself as an observer to the sequencer. And on notify, the sequencer sends out a notification message whenever you pass the goal, right? The finish line. And on notify, it pushes back the current lap time into a vector of lap times. And then it sets current lap time to 0. What else? It's got some functions here. You can get the current lap time. You can get the total of all the laps, which makes use of std accumulate. That's a nice little algorithm that accumulates all the values in a standard container. That's why we had to add numeric here to get access to that function. And what else? We get the amount of laps that we've done. That's about it, I think. There's not much to it. It's pretty self-explanatory, so I'm going to move on. What do we have next? Let's go to added a lap display. So this is the thing that actually displays our lap stuff onto the screen. And I made that its own thing. It's not part of the ship. It's a UI object is what it is. And it has, I mean, the object itself doesn't have too much. It just says some information storing the font for and the color, the position where it's going to be displayed on the screen, and it has a reference to the ship. But all the action is actually happening in the drawable class, which is internal to lap display. You know, the same pattern that we've been using for all the things that are drawn on the screen. So what does it do? Well, it uses a string stream to concatenate all of the information, all the lap counts, and then it draws that the string that is built up in the string stream onto the screen. And that's about it. Yeah, there's not much to it here. Oh, there is one thing that is kind of interesting. So here we've got a for each loop. And it's doing a for each time in ship timer. So what does that mean? Well, let's go to timer for a second. Oh, we can't because we're not in our code. We're in our what is it? Our change log. So where is get timer? If I can find it. It's not that important, but yeah, timer. So this just returns a reference to our lap timer. So how can we do, for those of you who have used this before, the for each, it just iterates through each of the elements in a container. But timer isn't a container. It's not a standard container. It is an object that we've made ourselves. So how can you get it to work with the for each loop? And the answer is you add two functions, a begin and an end function that returns iterators. And if you do that, then your class any class that you make can work with a for each loop. So what this does is it just returns the iterators for the vector of lap times. And then it'll allow external functions to iterate through those entries in the container without having direct access to the container. So it's just a nice little bit of syntactic sugar there for you. And that's about it. There's not much to this. One thing I did though is I deleted the lap listener from game now. Because I think before, game would just count the number of laps and then display that on the screen down in this line here as a single number. And now that display is being handled by this lap display. We don't need game object to listen to the, I don't know what it was listening to before. I guess to the sequencer in the ship. So that is no longer necessary. And we add a lap display to game here. And down here we just call draw on lap display.getDrawable. So very simple. Now we get on to the part, the actual meat of this lesson, which is the screen system. So in any game, you're going to have different screens, different states where you're in. You don't just start in the middle of play, and then when you end, you just terminate the program. That's not how it works, right? You've got like a title screen, and you've got options, and you might have a pause screen. When you beat a level, you're going to have screens in between level transitions, at the very least. Other kinds of games are going to have more complicated systems. Like an RPG game, you're going to have a weird game loop where you've got different systems, like completely different systems working together. You're going to have a field system where you walk around in a town or a dungeon or whatever. And then when you get battle, I'm talking about like a standard JRPG here. When you enter battle, you're going to switch to a different system where you're in your battle system. And then you might leave a town and go into the overworld system. And anytime you might pause the game, and that'll put you into, or not a pause, but like enter a menu, and then you're in your menu system where you can organize your inventory and your equipment and such. So there's lots of different screens in a game, and you've got to manage that shit. So one of the ways that I've thought of managing the game state before is with a state machine. Now the problem with this is the way that a state machine is generally implemented is states are mutually exclusive. So you're either in the missile state, you're in the city destroyed state, or you're in the pause state. So when you leave this state, the state gets destroyed, and now you're in the paused state. And then when you return to it, you've got to recreate this state. But that's like a huge waste of resources, right? It's a waste of time. You've got to destroy all of your game objects just to enter the paused state. And then when you leave the paused state, you've got to recreate them all. What you want to be able to do is when you pause the game, you want to put your main game state in like suspension, kind of suspended animation. And then when you unpause, you want to resume it where it was. Now there's another problem with this situation here, is sometimes you want to have multiple screens active at once. So you want to have a situation where you have multiple states active at once. But state machines, that's not the way state machines work, right? States are mutually exclusive. You can have substates, but you can't have two separate states on the same level active at the same time. But take like, let me think here. Take like an action RPG where you have a menu system. And when you enter the menu system, the game doesn't stop. I don't know, like maybe Dark Souls works like that. I've never played the game, but I've seen it online. And so you're going to have your main gameplay screen, and then you're going to have a menu screen that's overlaid on top of the main gameplay. But the main game doesn't stop. It doesn't go away. You can still get hit when you're working in your menus. So you've got to have two separate states active at the same time, one layered on top of the other. And this is not going to cut it for that. So what I propose, this is not my own original idea or anything. I'm not scummy enough to try to pass it off as that. This is a pretty common way things are done. Is you don't have a state machine, you have a stack of states. And the top state is going to be like the master state. And the states below it are slave states. In your Dark Souls game that I've just made up here for argumentative purposes, you'll be walking around killing shit, and then you want to access your inventory. So you're gonna have one state on the stack, and that's your main game state. And then when you press the inventory button, the main game state gets pushed down to the second level on the stack, and the top of the stack becomes your inventory screen. And both game loops, or both process functions, or whatever you want to call them, in both of these screens are going to be active. They're going to run once per frame. But now the input that would have been going to the game screen is going to get intercepted by the menu screen on top of it, and it's going to get all the input. So your up and your down button presses aren't going to be moving your character. They are going to be moving your cursor in the menu. But your game screen is just still going to be working. If an enemy comes and attacks you, you're still going to get your ass hit. So this top screen here, the menu screen, will intercept calls, or not calls, but intercept input. But it will allow the screen below it to still process its frame update. Now, let's say you have a pause button as well. And you can pause either when you're in your menu or when you're playing your game. So let's say you've got your menu open, you got your game running, you press the pause button. Now the pause is going to be the top stacks in your master. And the menu and the game are going to get pushed down to number 2 and number 3. And the pause, there's nothing you can do in the pause screen, let's say. But you can unpause the game. So the pause screen is now going to intercept all input. And the only one it's going to respond to is the start button, let's say. But the pause button is also going to stop the states below it from updating every frame, because it's a pause. You want the game to freeze, obviously. So this one will inhibit the states below it from updating their frames. There's an example. And that is what we're going to be using in our game system. And that's going to handle everything from the title screen to the options menu, to the gameplay, to the pause screen, everything. And the way it's going to work is like this. No, like this. Yes. So we've got a system here. We've got two abstract classes, screen container and screen. And game is going to inherit from screen container. And then you're going to have screen classes like title screen that inherit from screen. And the relationship between game and your screen classes is game is going to be, it's going to own one screen. It's going to be composed of, this is a composition relationship. So title screen is owned by game. And title screen also has a reference back to game. And what happens is, for example, let's say you're at the title screen and you press start to begin the game. And then title screen will call a function on game and pass it a new screen for game to contain. So title screen will tell game, now you're going to contain this screen. And then game will destroy title screen and replace it with the new screen, which would be, so here's the next thing that'll happen after you press start. You'll get a count screen, which is just a screen that displays a countdown timer until the start of gameplay. And that countdown screen is going to contain the game screen, which will be rendered underneath it. So you can see the game, but you won't be able to accelerate until the timer runs down. Just like a standard Mario Kart style game. So count screen is going to inhibit. It's going to inhibit update, and it's going to inhibit input for the game screen, but it will allow the game screen to be rendered underneath it. And what's going to happen is then, when the countdown timer reaches 0, count screen is going to basically destroy itself and tell game that now you own game screen. One interesting thing here is that count screen is a screen, but it's also a screen container since it contains a slave screen. So it is going to inherit from both screen container and screen. So how does this look like in code? That's what we want to know. Let's take a look. So what we're going to do is we're going to go to, where is it? Branches, screen, here it is, screen. We're going to create the branch for screen. And we're going to check out our history. So here I've added a whole bunch of bullshit for screen. Well, I didn't go over this, but after I added a lap display for lap timer, I fixed something in Observer. Observer has a boolean that allows you to enable and disable it. And if it is disabled, it shouldn't notify all its listeners, but I didn't have that if branch, I didn't have that implemented in here. So it just ignored the enable variable. So I fixed that. And that is all. Let's go back to here. So I've got the screen system started. That's my first commit. So what did I change? Well, I added screen.h, and that adds the two classes that I showed you before. It adds the screen container, and it adds a screen. So screen container, all it is it has a unique pointer to a screen. So that says that this screen container owns a dynamically allocated screen object. And the screen class has a couple of pure virtual functions, one for updating and one for drawing. And it has what else? It has a protected function here that the classes which inherit it from it can use, and that's change screen, and that allows you to change the current screen. And this one it accesses the parent, the screen container, and it tells it now you should point to the new screen. So when you do that, unique pointer will now point not to this class or object, but it'll point to the new one, and in doing so, it'll destroy the old one. And yeah, it has to have a reference to its parent in order to do that, in order to precipitate the change of screen, as it were. And then we have the game screen. I'll get to that later. What is shield? What did I change in shield meter? Oh, I just added a pragma once up here. And okay. So obviously game screen is going to have a lot of bullshit in it, because this is basically doing everything that our game object was doing before. It's handling the input, and it's containing all of the viewport, the camera, the map, the ship, everything. But it does mostly the same shit as game was doing before. It has a object that listens for death and responds to it by ending the game. It has the map, the ship. It does all the updating, all the drawing and bullshit. All the same old shit we were doing before. But now game has become much lighter. Look at it now. There's barely anything in it. What does it do? Well, I mean, it does the same stuff in here. This isn't too different, but it includes game screen and it inherits from screen container. And then in game.cpp, what do we have here? So when game initializes, it sets the pointer to a new game screen using the make unique function here. So it sets the unique pointer so that it owns a game screen. And down here, in the update model, we update our current screen, whatever it may be. And in draw, we draw our current screen. And that's it. Super simple. Let me look here. Where's my history? There it is. All right. So this one, it just replaces everything with game screen. Let me see. I kind of want to show you guys the evolution as we go through all of these. In order to do that, I have to create branches at all these points. So what we can do, and we go to HUGS, right click on that, and we go Get GUI here. And that'll allow us to use the Get GUI. We'll look at visualize all branch history. So here is screen. Here's where we are right now. Here's the screen system started. That's the thing I just explained to you. I'm gonna create a new branch here. We'll name it HUGS 7.1. Here's the first branch for the HUGS thing. And we're gonna check this branch out. If we go back to here, it's gonna say, oh, shit has changed. Let's reload all. Build it, hope it works. And start with the debugging. And here it is. So it should be no real difference from what we had before. Oh, fuck. I'm fucked. There we go. Game over. And we're stuck. We have to close the program, which is a pain in the ass. So the next thing we're going to do is we're going to go... Oh, where's my history? There it is. We want to restart the game after death. And what this does, we've added another member to the class, and that's the graphics. And the reason is because we need graphics when it's always been a part of the constructor. But now we want the game screen to be able to construct another game screen so we can restart the game after we've died. So in order to be able to construct another game screen, it has to remember what the graphics object was so we can use it in the constructor. So what we do is same bullshit as we've done before, except we keep a copy of a reference to graphics. And so in handle input, we check the death listener to check if we're dead. And if we are dead, then we also check to see if the enter key has been pressed. And if the enter key has been pressed, we call change screen, and we pass it a unique pointer to a new game screen that we've initialized. So this is beautiful, this game screen system, because before, when we just had the game object, if we wanted to restart the game, we'd have to reinitialize everything. We'd have to create a function that clears out everything. But here we just call the constructor and we get a whole new game screen, fresh, ready to fuck up our ship with black holes and nasty controls. So let's see how this works with Git GUI. We want this one. So we're going to add another branch right here. We'll call it H72 create. And we want to also check that branch out. Where is it? I always pick the wrong one. There we go. So we're going to check this out. And wait, it should say something has changed. Do you like? Let's build. So now the game should automatically restart once we've died, which shouldn't take very long at all. Let's just move this over here. Oh, and we're dead. So now we press enter, restart. And where's my black holes at? Come on. There we go. Press enter and we restart. Fair enough. Working as intended. We don't want that history. Let's go back to changes, view history, and see what we've gotten. We don't want this. We want to change back to lap timer. So we'll go down here. I'll pick the right one this time. Well, let's change to this branch now. And we'll see what we've done here. So we've got deferred screen replacement. What does that mean? Well, what we were doing before is we were immediately moving the new screen pointer into here. So we were changing the screen container's pointer automatically, immediately. Now what we're going to do is when we call change screen, we're going to hold the new screen in a pointer called on deck. So there's going to be a new unique pointer, and it holds the screen that's the screen that's going to become the new screen. But we don't immediately replace it. We wait until a call to end frame. So there's going to be a new function that's called every frame at the end, called end frame. And we only replace the screen at the end of the frame. Now the reason that we're going to do this is, I guess it's easier if I look at what I did next, because I made this change in order to enable me to make the next change. So let's look at that. We're going to go here, create new branch, H7. This is actually really ugly. I made this title screen and I figured out we're going to put some graphics on the title screen. So this looks horrible. I'm not gonna lie, this is pretty bad. It looks like a clown just threw up on the screen. But there's your title screen right there. Yeah, choke on it and die. So when we press enter, then we start the game here. Now, ostensibly, I made the deferred screen replacement so that that would work. But I'm not sure why it wouldn't have worked without deferred screen replacement, because I made it like a long time ago. Handle input, you press enter, and it changes screen to the game screen. That's fine. But why wouldn't that work with the old system is what I want to know. So let's just try it with the old system and see how it works. We're going to go back to title. No, we're going to go back to screen. And we're not going to use on deck. So we don't want this. We want parent dot p screen is equal to that. Right. And we don't want end frame here. And if we go back to game, where is it? Toggle. We don't want this. We'll start in debug mode. And we'll see where that takes us. All right. Press enter. Get an exception. Okay, so this is what I was expecting, because obviously there was a reason why I did that. But I want to know what the reason was. So we call update. We're calling update on title screen, but since we pressed enter, title screen has already been destroyed. So the question is, why are we calling update on title screen? Oh, okay, I know why. Wait, do I? Where is update? Here it is. So first we call handle input. And what handle input does is it checks to see, if we're still drawing this, or if we pressed enter, and if we have, it changes the screen. But after we finish handle input, we go into here and we start trying to draw our bullshit graphics on the screen. The problem is that if we have already transitioned, all this shit has been destroyed. And so when we try to call brush, b.step, it's accessing memory that doesn't exist anymore because we've already destroyed it. So the reason I made the deferred system was so that even if we call this after we've done our change screen, it'll still work because it doesn't get destroyed until the call to end frame. It doesn't actually get replaced until end frame. And until then, the new screen goes into the on deck pointer. What I'm thinking is what I could have done now is I could have just put handled input at the end, and that would have probably solved the problem. But the thing is that you can't always just move things around and expect it to work. So, yeah, that solved it for this one. But I probably was thinking at the time that I was like, well, this will work for this time, but it's just a band-aid. It's not a full solution. So that's why I used the on-deck system. I figured that would be much better. And then you wouldn't have to worry about whether your change screen would fuck something up later on. So that's what I did. And it seems to have worked. All right, we're going to We're going to undo all this bullshit. Undo. Undo. And undo. Okay. Now, let's take a look at what I've done next. We're getting up there. So here, this is probably not that important. I'm just going to go to branches. We're going to go back to our normal screen branch here. And we're going to look at changes, view history. So here's what we looked at. Next one, separate input and update. Fairly simple. We just create a separate function for handle input and for update. And we call them separately. I'm not sure why I've done that, but it seems like a good idea at any rate to handle those separately. So I did it. And remove that from there. And in game.cpp, now we call, in update model, we call handle input, and then we call the update. Fair enough. It seems like a good idea to separate those things out. And so it has been done. I might have had a specific reason for doing it, but I can't remember. It's not important. All right. Start countdown screen. So here's that countdown screen that I was talking about. That displays a countdown before it actually enables the game screen. So here is the important part in title screen, and that is when we press enter, we change screens to a count screen. And the constructor for count screen takes a screen pointer for the screen that is below it. So the count screen is going to be master to a game screen. So we nest these make unique calls. So let's look at count screen, because that's where all the action is going to be happening. It's pretty simple. So what do we got here? So in its constructor, it takes a child screen and it moves that into the child pointer. It also sets the child screen's pointer, the parent reference, to itself. So it creates that, it creates this relationship here where we've got count screen owns game screen with a unique pointer, and then game screen also has a reference back to the count screen. All right, so what do we got here? Update is going to just basically count down a timer, and if the time is lower than a certain threshold, in this case it's lower than 1, then we set the parent of child to be the parent of the current screen, which is to say, game screen, instead of having a reference to count screen, is now going to have a reference to the game object. And then we call change screen, which is going to, wrong thing, which is going to change the relationship. So now game is going to directly own game screen here, and count screen will be destroyed. But that's going to be deferred, right? It's going to first go into the what do you call it? The on deck pointer thing, I think. Let's look at screen here. So we change. Basically, we've changed screen container here, the parent, from a reference to a pointer. And the reason is because we're going to, before, where is it? Before, when an object was created, its parent would never change. It would always have the same parent. But now we've got the situation where its parent has to change. So the game screen, its parent, it starts off with its parent being count screen. But then its parent changes to the game object when the counter goes down to 0. So we change this to a pointer. And because we changed that, we've got to change this, and we add a function that allows our screens to set the parent of another screen. And this will allow a master screen to set the parent of a child screen. All right. And I think that's really all that we need. All right, so now when we pass in, when we create an object, we don't pass it we don't pass by value or reference, we pass by pointer. So we've got to remove that there. Yeah, that's about it. Nothing too spectacularly amazing about this. And it should work. Let's just have a quick look at how it works. We'll go... Ah, it looks ugly. The only one thing I like about this title screen... Fuck that. The only one thing I like about this title screen is that you have the black characters, and then as the colors come in behind it, the name of the game gets revealed. That's the only thing I like about this. Otherwise, it looks like a clown barfed on the screen. So here we've got the countdown timer, and then when it gets to 0, we start. Now, you might, depending on whether the screen captured that frame, you're going to notice that right before the transition, the screen goes blank for one frame. Exactly one frame, it just goes black. It blinks. And the reason is, so what happens is it does a test here. It says, if child, then draw child. Why does it do that? Because on the update here, if time is less than this, then we call change screen and set other parent, and we lose our pointer to the child. We lose our unique pointer because the child is now going to be held by the on deck unique pointer. So that's a problem. Now we don't have a pointer to child, we can't draw it. So for the very last frame before our transition, we get a blank screen underneath the counter, and it blinks and it looks stupid. This will be fixed later on. Let's continue on with the explanation here. I have no idea what this is. Title screen pretty. What does that mean? I probably changed some bullshit about how the title screen works. It still looks ugly, trust me, because it is ugly to this day. I just changed a little bit about the way that the colors change, I think. It's not important. Don't worry about it. I was just fucking around. Seriously, though, if any of you guys can come up with a better title screen graphic, by all means, like, let me know, and I will consider putting it in. I'll probably change it at some time, but it's not a priority right now. And it looks like ass. Feel free to run it for yourself and see how assy it actually looks. But enough of that. Let's keep on with the history. So we have organize source filters. Oh, okay. This one is super simple. What I did was I added folders so that all these files are now organized into folders, which you will see when I change the branch to the top of the screen branch here. So let's take a look at changes. Now, fuck the changes. Let's take a look at the folders. Look at this. Now we've got a folder for all our screens. We've got a folder for some UI objects, structures and algorithms, physics stuff, graphics, stuff with a framework. Beautiful, beautiful organization. I love it. Okay. And the last thing I did was it's a weird one. So I'm gonna take a few minutes to explain it. But what I did, so throw change abort state and recursive. What does that mean? So I didn't like the blink that happens when we change states. So I fixed the problem, but I did a bad thing, and I'm going to tell you why. The way I fixed it was by using, what do you call it? Exceptions, by throwing an exception. If you recall, the problem we had in the beginning, the original problem was that once we've changed states, if we tried to call, wait, let me just go to screen. So once we call, where is it? Where's change state? So once we call change screen here, the pointer, the parent's pointer to P screen is not going to point to the current object that called change screen. So if we try to do anything with the current object after change screen, we're going to, our compiler's going to, or not a compiler, our program's going to shit the bed. And the way we solved that was by having an on-deck pointer and holding that screen on deck until the end of the frame and then destroying it. And that means that the procedure for the updating and the drawing of that screen can still happen, and it won't shit the bed. So that's what we did, but that caused the blinking of the screen there when we had a chain of two. We had something like this. We had a chain of two screens, and when we changed screen for exactly one frame, this screen here wouldn't get drawn. That's the problem we faced. So what I propose doing is, instead of putting the new screen pointer on deck and changing it at the end of the frame, what we do is we change it immediately. But then we throw an exception. So we have a new exception type called just change, and it inherits from exception. It doesn't have to, but I just did because I wanted to. And when we throw change, that will allow us to immediately jump out of any functions that we're into, because that's the way exceptions work, right? It immediately unwinds the stack and then jumps up to the next level. And it keeps doing that until we reach, where is it? It's going to be in game.cpp. Until we reach a try-catch block. So the exception is thrown in P screen at either in handle input or an update, and it immediately stops processing anything for P screen. It jumps out to this point here. It catches the screen change exception, and it calls update model again. But this time when we call it, now it's going to be with the new P screen. It's not going to be with the old one, because what happens is the exception is thrown after P screen has been changed. So this will allow us now to process the same input, or what's left of the input, or the same frame, but with the new screen. Now you can say this is dangerous because we're recursively calling this. What if we have a situation where one screen transitions to another one and then it transitions back? But obviously that's dumb. I mean, if that's happening in your game, you got something wrong. You're probably just going to give someone an epileptic seizure if you're transitioning screens every single frame. So we can call that the epilepsy prevention routine. It just freezes your game if that ever happens. But anyways, so this works. This is how it works, and I like it. I like the way it works. It's very nice, but there's one catch, and this is not the way you're supposed to use exceptions. And C++ programmers, when they look at this code, they're going to say, "You are a fuckhead, and I hate you." So that's why I don't recommend you ever do this, but I did it because I liked it. I didn't do it because it was the right thing to do. Now, the reason why you shouldn't use exceptions like this is, well, there's a couple of reasons. Exceptions are generally only used for exceptions, for things that are exceptional, things that you could not have predicted as a programmer. Bad things happened and you had nothing that you could do to stop them. For example, one kind of exception is going to be file I/O exceptions. For example, you try to load a file that should be there, like an audio file, a sound effect, or something. The sound effect isn't there. That's a problem, but it's not a problem with your program. It's a problem with the environment. That file should have been there, but maybe the user deleted it or something happened. And so that's a problem, but it's not a problem that you could have fixed ahead of time as a programmer. So that's an exception class problem. Or you're trying to create a file, but you run out of memory on the hard drive. That's another exception type deal. Other things where exceptions can often happen is, for example, networking. You know, connections can just drop spontaneously. You can have an internet outage or an outage in a router between the two hosts or whatever, and that can cause a problem that's not part of the normal processing. These are the places where exceptions are generally used. And when you use exceptions in ways other than these, you're not writing idiomatic C++, which is to say you're not writing C++ that someone would look at it and automatically understand what you're trying to do. When you use things in a way where they're not normally used, you make your code harder to read for other people. That's reason number one why you shouldn't use it. Now, reason number two isn't a real big deal here, but generally, you shouldn't use exceptions in place of like normal control flow, like just like a return statement, because exceptions are slow when they are thrown. Exceptions are slow when they're thrown, but they're not slow when they aren't thrown. If that makes sense. So they are optimized, because obviously when you put a try catch in here, there's going to have to be some kind of test to see whether an exception has been done. There's going to have to be a test injected in your code somewhere to see whether an exception has occurred, and if so, jump to the appropriate point. And also do a bunch of stack unwinding bullshit as necessary. So the way the code is made is that minimize the amount of work you have to do in the normal case, but as a result, when an exception is thrown, it's much slower because everything is optimized for the case where it doesn't occur. So if you are using connection or exceptions in program flow, and let's say you're using it inside of a loop and it's throwing an exception, hundreds of times a frame, that's going to actually cost you some processing time. That's going to slow down your program appreciably. Now, in our case, we're only throwing an exception at most once a frame, and usually probably only once every, few 10,000ths of frames or something. You're not changing screens all the freaking time. So it's not a problem from a performance point of view, but it's definitely a problem from just from a style point of view. Other C++ programs will look at you funny if you write code like this. I'm just telling you right now, I really like this solution to this problem, but I can't recommend it to you on the grounds that you'll probably be ostracized if you program like this. So I'm going to use it for right now, but I'm not going to recommend it. This is one of those cases of do as I say, not as I do. Now, there is a better way of handling this problem, and that is shared pointers. We can get this same behavior with shared pointers. Maybe. Now that I'm thinking of it, it might be a problem, but I think shared pointers will solve our problem and will not piss off other programmers. But I don't want to introduce shared pointers just yet. I have a much better topic for introducing shared pointers. And after I've done that, I might return to this code and see how it would be done with shared pointers. But the other alternative is you have, where is it? Wow, where's my fucking thing? Screen. So you have change screen, return a value, a Boolean value, basically signaling whether the change has occurred, or that doesn't make sense. But basically, whenever you change screen, you have to return up to the top and return a Boolean value. So what is it going to be? Update and handle input are going to return bools telling whether or not the screen has been changed. And anytime you do anything that could possibly change the screen, that function, anytime you call a function that could possibly change the screen, that function has to return a bool telling whether the screen has changed. And you propagate those change signals up. And that would allow you to basically get the same benefit as throwing an exception. But you would clutter up a ton of your code with if statements. You'd have to check the result of every action to see if it changed the screen. And if it did, return true. And then everything up the hierarchy would also have to check that bool to see if the screen has changed. If so, return true. So I don't like that. I like throwing an exception. So that's what I'm going to do. And if you don't like it, you can fight me in real life. That's all that we're going to talk about for the screen. It actually took a lot longer than I hoped. I was hoping to get this done in 30 minutes, but it's not going to happen. Maybe I can edit it down to less than an hour, but probably not. Anyways, I've gotten quite a bit farther ahead in this project, and I'm hoping to get a few videos out in the coming weeks and get some progress done. It's actually looking interesting, and that's why I'm into it now. I'm like, oh yeah, I want to make some more of the HUGS program. Remember, if you want to enable my crippling addiction to Magic the Gathering, you can go to the forum and you can come up to this nice, homely, welcoming chat we have here and say hi. I want to waste all my time playing a game for babies. And then I will say, welcome to the Thunderdome. I don't know. I'm just rambling now. I should probably stop the video. Goodbye and see you soon.